Всем добрый день. Приветствуем вас на докладе «Вам письмо. Старые и новые атаки на почту». На нем мы расскажем вам про уязвимость.
Hello, colleagues. We'll be talking about email attacks. We'll talk about injections, the problems we see, and how to deal with them, and how we can exploit these issues. Hopefully, we'll see a QR code for your questions throughout our discussion, and we'll have a Q&A session later. Yeah, and you'll have a T-shirt for those who ask the best question.
Что ж, думаю, можно начинать. Все сосканировали.
Okay, I hope you have used the code. My name is Elizaveta Tishina. I work for DeteAct. We test the mobile apps for penetration. I have a Telegram channel where I talk about some interesting topics from the information security domain, and I'll be responsible for some case studies of the issues we are talking about. I'll try to explain it to you in plain language. I'll show some test benches and some research we have performed. Hello, my name is Vsevolod Kokorin. I have the sponsor nick. I'm a security investigator in SolidLab. I also have a blog. Sometimes I play CDF in Kapatset's team. Well, the first issue which concerned us is the incorrect parsing of email addresses which further fed to the email servers. So let's talk about the addresses, the structure. So there are several specifications: RC 822, 2822, and 5322. The first one is the Internet standard, and the later ones are the updates replacing the older ones. This slide shows a valid email. It is in line with the specification rules, but the only thing we need to understand now from these rules is the set of valid constructions we can inject into the email to check the vulnerabilities of the parsers of emails. Here we have the more or less signs, we have the square brackets, the parentheses, and also the quotation marks. Okay. We can split this into parts following the explication. So we can see that we see the name, the username. In this case, it is Lisa. Inside this more or less signs, we have the what we call the email address. Optionally, we can also use the local part of the name, so we can add quotation marks there, especially if we need the special symbols like test with the exclamation mark. And we can also have the square brackets. Here we have the IP addresses. This is local host 127.0.0.1, and then we can see the parentheses. So this is the comment, it's me. So this is all valid and under the specification. If you parse this properly, this will split into two parts. The first one is the real name, which includes the name displayed and the comment in the address. So we just admire the real name, we show it to the user, and that's about it. And the second part is the address we'll need to use when interacting with the email server. Okay, now we'll have a look at what happens when parsing goes wrong. So we have a registration form in a system. Here we have a white list of domains, so you cannot register if your email address is beyond the domain hacking.local. It is developed based on the third version of PIPE, and for the address, the email address, and for sending the letter, on successful registration, you have the Python library. It is called email, and last year they found there the CVE 2023-27043 vulnerability. And this is about incorrect parsing of the email address, and it covered all Python versions up to 3.12. And the issue was in two functions: the parse addresses. There you can split the address of the email into two parts: the real name and the address of the email. And to the left, you can see this case example, how we compare the address against the whitelist. I use the parse order. It takes the parameter from the email. It splits this with the @ and compare it to the whitelist, hacking.local. At the bottom, you can see how this function deals with the email address having an incomplete construction. So we can see within this more or less signs the QWQOR and so on, but it wasn't found that. It only sees the a part of it, and the real name is empty here. Well, this is not the way it should be, because we have an incorrect construction. We have these square brackets, which are not closed.
Извиняюсь. И получается, что как бы некорректно парсится адрес электронной почты, и в целом вы...
And the address is not parsed well, and if we use this address further, well, despite the fact of this incorrect parsing, it is still valid overall, and it's not a problem. And the problem occurs when the original full address is saved by the app. So what happens next? So let's have a look at this. So the attacker's address and the address to be used by the server is the QWQOR and so on. So within this more and less signs, but it'll only see the hacking.local. So we'll send a request to the whitelist. We'll satisfy the request, and this email and the other emails will go to the address of the attacker, despite the fact that it is not part of the whitelist. So this incorrect parsing of the email address and the use of the full address instead of the sparse address, the attacker can satisfy the whitelist and further receive emails outside of the whitelist. Okay. Now let's talk about the structure of the email address again. Well, I dealt with this. I read the RFC, and here you can see that the domain can have a domain literal, some symbols which are in the square brackets. And this is the text, the printable US ASCII, so all the symbols, 32 is space, so everything going after the space, with the exception of special symbols like the square brackets and some other symbols. This is done for convenient IP addresses sharing inside email. If in some servers you just send name at IP address, it will not let you do this because it believes that things going after the first dot will be the top level domain. And for this and for some other specific goals, we introduced this solution.
Соответственно, я решил смотреть.
Okay. I decided to see how it is implemented. And here you can look at the Python code. And we should remember that we only have the ASCII symbols without special symbols. We see whether Python does it this way, and we see that it's not the case. So this is the latest Python, and you can see that it just receives all the symbols, no white, no black lists, and it even uses the angle bracket and the square brackets inside other square bracket symbols. So I thought that maybe Python developers are bad. Then I looked at other solutions or other ways, like address parse JavaScript. It was published 8 years ago, not changed ever since, and about 500,000 people a week have been downloaded it. We add a strange payload here. The address parser issue in JS is that inside the square bracket we can close it, and it will be looking for the last one, and we can also add a lot of special symbols and so on. So why are we doing it? We'll talk about this later. This is the most popular JS library. We try to look what is going on. 500,000 downloads. This is one of the main software pieces for recognizing the addresses, SMPT addresses, and we can see that it's implemented in a wrong way. I mean, well, similarly, everything looks much better because we only have square brackets, opening square bracket, which is authorized, but you can see at the end the word Russian. So what's the problem? The problem is that in the RC they say that we need the ASK symbols, because most parsers, when they use the SMPT protocol for this address, they will decode it not as UTF-8 but rather as the ASK symbols, and this UTF-8 will be split by bytes and other components, and this way we can encode the symbols we shouldn't have there. This is just an example. I could share with you 10 Rusty libraries, Ruby, PHP, and C#, but the sad part of it is that in the libraries I have tested, only Delang deals well with square brackets, well, but not exactly well in terms of RSA, but it doesn't let in injections of random symbols. And the next problem we run into is not enough filtration or special constructions when you share the user data with the client. Let's have a look at the SMTP protocol. It is used to send emails by email. To the right you can see the legitimate traffic, SMPT traffic recorded in Wireshark, and every transaction there looks like the client-to-server communication. The client sends commands and the server responds to them. The most important commands we should know here is hello or hello. So this is for opening the connection and to identify the client to the server. Quit is to close the connection. And another important thing is reset. This is to reset the transaction data without closing it. We have other commands here. We can call them envelopes, so they open the email and give us data. So this is the mail from command, showing the sender, receive to the receiver, and data, which opens the data section and the email content. The email content has the title and the body of the letter. The body is the text. So the message one user wants to share with the other one. So the title or the header, so this is an optional or a technical thing, and here we include the sender, the receiver, the subject, the type of data, data itself, and so on. And the interesting thing is about copies. So the emails of other users who will also receive a copy of this email, and you can have hidden copies, hidden from other receivers. And here we have some special SMPT construction. So we have a space to split the command and the argument. Then you can also have the CRLF to close the command and to change the lines in the content. And the server, when we start the data section, we can see the data is closed with the CRLF, CRLF.CRLF. So this is to close down data. Okay, here is another case and another testing bench. Here we see the address, the text. This is JS based. We see a library, SMPT client, and the postfix mail server. Well, this is an HTTP request whereby the user shares the address of the email. So this is the mail form, then text as a data form. Then we see the argument, mail from. The text is shared as the content of the email in the data section. So this is the HTTP request and the traffic. So there are two entry points, the argument mail from and the content of the email, the data section. Let's see what it looks like in the SMPT client. Here we have the mail function, and data command and function are the same. They don't sanitize the data well enough. Only for mail from, well, they don't sanitize the entry. So it's just an argument as mail from the email client. And for the data section, an interesting thing happens. They swap every dot with a colon. And this is done to prevent the user from using CRLF.CRLF by closing this way the email and introducing commands for the email client. But see, you can see there is no identifier G global, so only the first only the first dot will be replaced, so you can bypass it. If you want to bypass it, we can add CRLF.CRLF to the data section. This way, the user can start several lines with a dot, so that the first one is replaced by a colon. You can see it to the right. And this next CRLF.CRLF will be recognized as a special construction, ending the letter in the context of the form.
Номером это информация из формы.
So the first one is information from the form, the email address.
Это полезный
Now the next one, well, we can call it payload,
обходила санитизацию.
which bypassed sanitization. And then number two, we also have the form data, but these are injected commands for the SMPT injection. Here I decided to initiate a new message. I open the envelope, I add data, and this way we can do impersonalization, so we can replace the sender with another sender. And this is like a phishing email. And this way
Мы на
we receive,
пользователь, который является
I mean, the user who collects requests receives letter 1, only the part which was sent initially. But number 2 is the second letter, which was initiated as an SMPT command. And this way we can send letters using somebody else's name, so impersonalization. And there is another funny vector. Here we need some other conditions. You should have one connection for all the users, and the email server shouldn't stop the connection if there are any traffic issues. For instance, if there are some issues with the processing. So some servers stop it, but Stolber, for instance, doesn't stop it. So this way, the attacker can open the envelope without opening the data section, and then the next email 2 from another user, will be given to the attacker if the attacker says that he is the receiver, and then the attacker will hijack the email of the next user in this chain, since mail from will be ignored. Okay, now we can see more people understanding the functions of SMTP. Now let's talk about the things I have already mentioned. So we, this way, added any control symbols, including the serif.
Ну, просто
And so we can add it to the square brackets.
заработал. Возьмем для примера C#.
Let's have a look at C# as an example. What happens here in this code? Here, we take an SMPT client, we connect with the credentials and so on, and we don't control anything except for the field where we send it. Why C#? Because here we have the standard system.mail library, and you can get this
Копилоту
with GitHub, or you can ask for this send message, some services. Well, serif injections, they don't usually work.
mail address.
So we have the mail address in C#, which should be an argument for the function sending the message. And this function will process the address. So it removes the serif servers symbols and shows or returns mistakes if the address is wrong. Maybe it is not the way it should be in terms of the structure. But you remember our square brackets trick. So we can see it
И посмотрев исходный код,
didn't respond to the attack. So it validated the function mail address. So we can see that it doesn't do any other validations or changes. So this line address will be injected into our SMPT packet exactly like that. And then you can generate this Gmail address. So we don't show you the long line here. So here you can see a translation of this. So we remember the rset command. So we do it through translating the line, because the first address is not valid. So we'll go further. Then we'll show mail from and the recipient, and we have data with the body of the letter. And so we can answer this mail from question. When we test the service, we can see where this mail address was sent from, so the domain. So we receive the message in a valid way the first time, and then we just swap it. Then we can show any recipient and any body. This is a big problem, since, as I mentioned, in a standard C# library, this is an issue, and there are no patches for this. For some reason, I decided to, open this 0-day, and there are many sites using C#, and they just use this mail address construction. So you can add to the auto scannings the template, which will send messages to your address, as you can see to the left. So changed. So this is the message which was changed, and we received it to our address. And the last issue is about misalignment of participants. So we're talking about implementation issues which cause problems. Well, email is a sophisticated issue. We have client and a server, and many other things, but we'll be focusing on this too. The mail user agent, so the user agent which sends letters, and the user client, the interface which lets the user interact with the email service, and also the mail transfer agent, MTA, which is a chain of mail servers which share,
То есть и общаются они
which convey the email from the
окончание.
sender to the receiver, and they communicate using SMTP. So we talked about some special construction, and you remember SolidLab closes data. But the problem is that sometimes data is closed for some reasons by these constructions.
Поскольку они могут быть внедрены в содержимое.
And they can be injected into the body of the letter. So these are the headers and the body.
Историю изучили
All of this was discussed in detail by the SEC Consult experts. This is an Austrian company. This research made it to top 3 in the product figure blog. So these experts shared the data on the chain of servers sharing the mails, and this also showed that some servers also consider these extra constructions as valid ones. Some details. We have
не фильтруют.
an outgoing server which doesn't filter and doesn't read the constructions. They are just a text for it. And if the attacker injects these constructions, they'll be considered as text. And if there are any encryption like commands or else logging, like for user authentication, this doesn't matter because this is just a text. And then it goes to the receiving server, it goes to the SPF, DKIM, DMARC, security tools, because our initiated commands are still text, and the sender and receiver are just text. When the mail makes it to the receiving server, which will share this letter or email with the user, if the server reads these constructions, these extra constructions at this stage, they will become valid constructions, like SolidLab, and the attacker, having injected this construction, can close the email and add and inject SMTP commands to be executed by the receiving server. And this happens following all the security screens. So this can be used to send legitimately looking emails through impersonation using the names of other users. Here you can see the list of products which are vulnerable, since the outgoing,
Exchange Online.
like you can have Microsoft Exchange Online and JX products, JMX products, they ignored constructions like that. They didn't filter them and they didn't recognize them as valid. And the receiving server, so the Cisco, SendMail, iOS, SMPD, Postfix, XSIM, and Search Mail. These receiving servers considered these constructions as something valid, and they could split the email this way.
So,
Говоря о несогласованности участников,
back to the unsynchronous of the participants. In the beginning of this year, I was thinking that everybody passes addresses differently. And when messages are being sent, you get the from header
отправителя.
where the client takes the information from the current sender. It's important to note that all modern state-of-the-art mail servers validate this address so that you couldn't just send from Vasya at .com looking like Petya at mail.com. So let's see how the header is constructed. We can either identify mail address or the angle brackets, second example. Then you can use quoted or unquoted names, and starting from line 4 starts what happens more rarely, adding a comment. The standard added this comment
Оно
capability for no obvious reason. It's not even reflected by most modern clients. When you enter email, you will hardly have some separate comment block.
просто разворачивается.
Modern services usually unwrap them as the continuation of the name. And what's the most interesting thing is this group. We'll talk about it a bit later, but now it's just a merger of several addresses. And the last thing is the sender header. According to the RFC, it is similar to from, in order to describe the situation where one needs one. And that basically is a quotation from the RFC. So imagine we have a secretary, and they are sending from their own name, sender, but from is different because they're sending it on behalf of their boss. And so not always when you validate from, the sender header will be validated.
Чего я смог достичь?
So what I was able to achieve, straight off, I was able to spoof
Такими сайтами.
email addresses between such popular SMTP clients as Gmail, Yandex, Outlook, mail.ru, and the rest. We'll take a look at some payloads and why they work.
Возьмем SMTP.
So let's take the Gmail SMTP server, and we'll send from it a message where spoofed at gmail.com will be shown in angle brackets. And here the problem is that the Gmail server believe that you go to the email and that means that that's the beginning of the name. Of course, it doesn't match what RFC has, but this is the way it thinks. Allowing it, because at the end it has this magic line with my address that I really own, spoofed bug bounty. And we'll see this magic email with the body of Obobus and Mobus from the address spoofer at gmail.com. So therefore,
Мы можем от любого имени
we can
отправлять
send emails from any sender. Also, I have this NodeDev in Golang CV 2024-24-784.
Соответственно, в чем был смысл?
So what was the meaning of it? Golang wasn't opening up comments absolutely correctly because there was a comma there, so it was first splitting by a comma and was then looking at the comment. And comma is a valid symbol in the comments that led to a situation where we could send from a different SMTP server to the SMTP server using the Golang parsing an email that contained a spoofed address. Specifically, this one was applied to Proton Mail because that gate was written in Golang, and so this payload allowed writing email from an arbitrary address.
Группам возвращаемся.
Now going back to group. So what's the essence of groups? Groups were introduced quite a long time ago, but nobody was really using them. The main purpose of this functionality is that you have a family. We've joined some addresses in it and are sending them by group using semicolon.
Почему они являются
And so these are two problematic payloads because according to RFC they're not valid because group name cannot contain angle brackets. It's a special symbol, but unfortunately not all SMTP servers understand this when they're doing the parsing, and correspondingly we get things like this.
Microsoft Exchange?
We take Microsoft Exchange and we send from Outlook from regular mail and will send a sloncer.bug bounty. What's going to happen? Outlook, as opposed to Gmail, believes that the group name may not contain angle brackets because it complies with RFC. So correspondingly, everything that goes after this, it believes to be a garbage, and it believes, okay, you're sending from your email address, and when it arrived at our Gmail, you can see the screenshot where DeteAct pass shows that Gmail has passed it as a group and converted it into a name. Because groups and comments are now resolved into names in most engines. So which resulted in us being able to write from Outlook and Exchange service to Gmail as if from any address. And now we expand the payload. At first, a spoofed was number one, and then it was number two. And we're now sending from Gmail to Yandex, Outlook that don't pass correctly, and so we get a valid email from the address that we're not controlling. I took Gmail and Outlook as an example. It's obvious that the same kind of problems affect other vendors. It's just that the payloads are the same, and you can even test it yourselves. And because we are running to the end of the presentation, plus or minus, most of the payloads will appear in my...
Да.
I'm sorry.
В течение часа вот появится по первой ссылке.
Will appear within this hour, if you follow the first link. And the examples I showed on C# affect solutions from other vendors. It's just that the payload will not be different, and so it makes no sense to consider them separately.
Спасибо вам большое.
Thank you very much.
Сейчас будем отвечать на вопросы.
And now we are going to take your questions.
Надо освоить технику. Так, ну...
Okay. Question one is from a guy called Dennis. When you're spoofing the sender over this way, the message will be marked as erroneous. Here you see DeteAct pass, SPF pass. The whole essence is that TKIM only checks the domain. It does not allow us to indicate that we've sent an email from, let's say, Sloncer info rather than Outlook.com, but it won't allow us to run this check.
Так, еще.
So, one more question about spoofing from Artyom Kornev. How widespread is the spoofing problem? You have to understand that this is the problem. This problem arises because everybody passes differently. And having tested the top 10 of popular SMTP solutions from mail providers in the Russian segment of the internet, I didn't find one that would fully implement the RFC. So basically, there are other ways to help. It was on slide 26. And what was on slide 26? Is it possible to get protected? So in this case, yes. All sorts of security mechanisms should be triggered, verifying the matching between main from and from, also that the user is authenticated. The authenticated user has a right to send this message, but again, take the situation with the SMTP smuggling, when at a certain point in time such injected commands were perceived as just text. In such a case, the security mechanism would be to get rid of some such special constructions. So question to you, how to fight SMTP smuggling if the SMTP command arrives after the security checks? So as a result of researchers bringing to the vendor's attention that problems like this emerge, in most cases the problem was fixed. It was mentioned in our presentation, more so in the context of mismatch between the participants in the email chain. To say that, yes, when different solutions are implemented differently and they're put inside a certain chain, then you get into such security breach situations.
Странный, но очень веселый вопрос. Я
Strange but funny question, and I have to answer it.
с тобой за
How much did Microsoft pay for not communicating? Well, actually, a funny question. Actually, I reported them about this vulnerability. They said it works by design. I asked, can you explain? And they just ignored me and stopped answering me. So that's why I decided to show it publicly.
Где? Антиспам? Именно про антиспам.
Specifically about anti-spam, one can say that it's indeed an interesting question. So, who asked this? Anastasia Koba. Anti-spam solutions, for the most part, process the body of the emails, and also a vector is quite possible.
Когда ты уже общался с человеком,
When you have already communicated with a person, let's say from your organization, and then your system already knows that it's not spam. So if you've been communicating with a person for a year, so not to run into a false positive situation, they don't send these emails into spam. And many of such spam solutions use email addresses that has already passed this kind of authentication, mail from, roughly speaking. And the essence is that once you got it from a spoofed email, it's not going to get into the spam list. So here the attack vector is quite broad within the company. I mean, the situation where the person has got access and spent some time communicating with everyone and then decided to steal something.
тестировали вы популярные
Have you tested popular email protection tools? SolidLab doesn't have any at the moment, so I haven't.
вроде интересное закончилось.
Well, I think we've run to the end of what's really interesting.
Тут был вопрос
There was a question
общению с Microsoft.
about CVE communication with Microsoft. It's not exactly about my presentation, but they have a portal. And as to the CVE, you can write them either yourself
SNIC.
or get a CNA registered following the SNIC type. You can approach me after the presentation. I'll explain it in more detail. So I think that's it.
Но в целом
On the whole,
нормального порядка вроде бы закончились.
I think we've run
Думаю,
through most
кому-то еще непонятно.
questions that we can take here. If your question has not been answered, you're welcome to come up to me one-on-one. And we need to award the T-shirts. There was one about security, protection.
Коллегиальным решением
Yes, so Denis Arbu 62 has won. So please come to us and we'll offer the T-shirt to you. Others are also welcome to come